Everyone, we will look at a problem called cyclic sort today. So this problem states that we're given an array containing n objects. So each object when created was assigned a unique number from 1 to n based on their creation sequence. This means that the object with sequence number 3 was created just before the object with sequence number 4. Okay. So we need to write a function to sort the objects in place, that's the important part, on their creation sequence in O of n time without any extra space. Okay. Let's assume we are passed an integer array containing only the sequence numbers, so each number is actually an object. Okay, it's a lot of text, so let's look at an example. So here we have an input array, and we basically have to return them in the sorted order, and we have to do that in place in O of n time. Okay, so this problem can be categorized as an array problem. Also, it's related to the cyclic sort type of problem. So let's discuss how we might go about solving it in O of n time and without any extra space, that is in O of 1 space complexity. So we have this input array 31542. So basically we have to sort this array such that each number is in their right spot based on the sequence number. So if this is a 3, this needs to be in the 3rd position, and that's according to the problem statement here. If it's a 1, it needs to be in the 1st position, 5 needs to be in the 5th position, and so forth. So here's the breakdown of the input array. At index 0 the number is 3, index 1 the number is 1, and so forth. So basically what we have to do, so we look at 3 here, so 3 we'd have to move 3 to the 3rd spot, we'd have to move 1 to the 1st spot, we'd have to move 5 to the 5th spot, and so forth. Okay, so we would have to do some kind of swapping here. So obviously we have to walk through the array, so that will be our O of n time complexity, and then we have to swap it based on whether the number as whether the index as derived from the value is equal to the number at that index. So I know this can be a little complicated to wrap your head around, so let's actually look at some code, and that'll make this pretty obvious. So we start from index 0, okay, and then while I is less than num.length, so this is num. So let's say we have a integer j equal to num I minus 1. So what does this mean? This is very important. So this j is basically the index that the value at I points to. So now we have to subtract 1 because obviously we are initializing our index, it's starting from 0, that's the reason. So then we walk through the array, so we have a 3 here, so let's just walk through it. So I equal to 0, so j is going to be num 0 is 3, so 3 minus 1 2, so j is 2. For the first time j is 2, I is 0, num I is 3, j is 2. So if num I not equal to num j, so if num 0, this is for the first time, not equal to num 2, in other words, if the number we get at index 0 is not equal to the number that is expected to be at index 2. So right, so essentially what this is saying is, according to the problem statement, 3 needs to be at this particular index, at index, it needs to be at the third place, it needs to be at index 2. 3 needs to be at index 2. So we are saying this is 3 at index 2. So in this particular case, it's not at index 2 because num2 is actually 5. So because 3 is not at this index 2, so basically swap these numbers. So what we do is we put 3 where it's expected to be. So that's what this does. And then we just keep going. So obviously we're not going to increment I until we make sure that the number at I is 1. So in the second go around, the number will be 5. So we just keep going. Now when we get to a state where the number at this index is what it should be, then we just increment it and we move on to the next position. So let's put that in code. So I have CoderPad up here. So we have to do the swap. So this should be very straightforward. So we need to swap the values at index I and j for input array. So then array I equal to array j and array j equal to temp. Then basically the sort just going to be this code here. So I'm just going to copy paste to save some time, and I'm going to remove these comments here. And so when we run this code, we expect it to be sorted. Let's see what we get. Oh, it's nums. Okay. I think something not right here. I think there should be length. Okay. All right. Another typo. Hopefully it works this time. Okay, there we go. That's it. So let me just make sure I have the right code in here. Okay. Now the time complexity of this is the time complexity of this is O of n. O of n, and because we're walking through the input array, and the space complexity is O1 because we're making changes in place without any additional data structure or any additional space. That's it. Thank you for watching.